This is a screencast for section 10.2, example 6, studying planar motion. So again, this particle isn't moving along the x-axis anymore. It's moving up inside the plane somewhere. It gets very, very cool in a second. Particle moves in the plane with position vector r of t equals sine of 3t cosine of 5t. Find the velocity and acceleration vectors and determine the path of the particle. So the position vector, which I should have called r of t, oops, I'll cross that out in a minute, is sine of 3t comma cosine of 5t. So then the velocity vector is take the derivative of the position, the horizontal position expression, and that's going to be 3 cosine of 3t. Then the derivative of the vertical position expression, so negative 5 sine of 5t. The acceleration vector, same thing. I'm going to take the derivative of the horizontal velocity expression to get the horizontal acceleration, and then take the derivative of the vertical acceleration expression to get the vertical acceleration. Now, it says determine the path of the particle. Well, I'm going to do that with my calculator. So in my calculator, I put in the position sine of 3t into my x parameter, and then cosine of 5t into my y parameter, found a good window after guessing a little bit, and I get this kind of lattice work type graph. So this particle, if you put this in your calculator, you can see how the particle moves along this lattice work. It's pretty cool. The now try problem number 33 says a particle moves in the plane with position vector cosine of 3t comma sine of 2t. Find the velocity and acceleration vectors and determine the path of the particle. So same instructions as the example. So that position vector, again I should probably be calling that r, is cosine of 3t comma sine of 2t. So velocity, I'm going to take the derivative of the horizontal position expression, then the derivative of the vertical position expression to get the horizontal and vertical velocity of my particle. Then take the derivative of the velocity vector to find my acceleration vector, the acceleration of the horizontal motion and the acceleration of the vertical motion. Again, finding the path. Well, I put cosine of 3t in for the x1 and then sine of 2t for y1. So I'm doing the putting in the horizontal position expression and the vertical position expression. Found a good window, and this, I don't know, Star Trek-y type thing is what I get for the position of the particle. So the particle is moving along this path. Again, very cool.